Our last two pairs of angles are a linear pair and vertical angles. For a linear pair, the definition that your text gives you is two adjacent angles whose non-common sides are opposite rays. What this looks like is if we have one angle. We will draw an adjacent angle. We'll make this angle share side AC. Then the other side needs to be an opposite ray to side AB, such that we get a straight line, 180 degrees. The easiest way to find a straight angle in a drawing is to look for a straight line with a point so that we have opposite rays and another ray jutting off. In which case, well, let's make this A prime, B prime, C prime, and D prime. We have angle B prime, A prime, C prime, and angle C prime, A prime, D prime are linear pair. Similarly, we see that angle BAC and angle CAD are another linear pair. So just like the name implies, we need to see that straight line. And then just remember that the two angles need to be adjacent angles. Okay, our last pair of special angles is that we have vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. That's a little technical, but what it means is if we were to draw two straight lines, we'll say they intersect at point O. We'll have A, B, C, D. Then angle AOB and angle COD are a pair of vertical angles. Also, angle AOC and angle BOD are vertical angles. Now, one of the things I marked in this picture that you might have noticed is I did mark that angle AOB is congruent to angle COD, and I did that by using a single arc line for both angles. And I also marked that angle AOC is congruent to angle BOD with the double arc lines. This is a theorem. It's going to be the first theorem we see, and it's going to be a theorem that you will try to attempt to prove in class. So if you want to start thinking about it now, it's probably a good idea how you would go about proving vertical angles are congruent. If not, you're welcome to Google it if you want to spoil the surprise, or wait until we work on it in class.